All right, everybody. Hi, and welcome to another session from Come Cloud with Us. I'm Chris Gill, and I'm here with my cohort across the pond, Abdul Kazi. Abdul, say hi.
Hi, everybody.
And today we have two awesome guests. We have Thomas Thornton and Nicholas Chang. So, gentlemen, please take a moment to introduce yourselves and welcome to the show. We appreciate you.
Awesome. Cool. Cheers, Chris. We have a slide on introducing ourselves,
Yeah,
but yeah,
that's it.
I'll start off. My name is Thomas Thornton, currently a senior tech specialist at a company called Kinos, Belfast based, so I apologize for the strong accent now. I'm currently a Microsoft MVP. I think it's my third year, and now a HashiCorp ambassador as well. So I've quite an active Azure blog at thomasthornton.cloud. Certainly feel free to check it out after this session as well. And over to Nick.
Oh yeah. Nicholas. I'm a platform engineer, and I work with Thomas. I with the same company, Canis. It's based in Belfast, and I have a blog as well. So nicholaschangblog.com, and I'm trying to be more active in the community. So trying to speak more, and yeah. So we got some slide, didn't I? Afterwards. I don't want to say anymore.
Awesome.
Love it, love it. So let me, if you don't mind, but
Yeah.
what are your specialties? What do you guys like really enjoy working on from that perspective?
Yeah, that's an interesting one. I like expanding my toolkit, to be honest. Currently, I'm a tech lead for a set of, I suppose, delivery teams for, full-time Azure, specializing in cloud native. So the likes of Kubernetes, the GitOps, cloud native workloads spanning across quite a fast Azure environment, which is, I suppose, huge. It's 90 plus subscriptions and so on, things like that. So quite some size to scale. I suppose my interest at the moment is certainly the likes of Terraform, infrastructure as code. That's really diving deep down, and I suppose an interest of that is what's coming next. The likes of Copilot and how Copilot can influence the likes of infrastructure as code, your application development, and so on. So it's quite a huge interest in the likes of DevOps and what's next in the future as well. And not just now, Terraform's fine, infrastructure as code, but it's moving towards the likes of natural language and things like that. So spending a lot of time looking at that, and I suppose huge interest in a particular area. So yeah, I suppose that's me in a nutshell at the moment.
Yeah. I think I'm kind of the same because Thomas got me into tech as well, so infrastructure as code. So I kind of fall in love with like Azure and infrastructure as code, and I'm kind of like currently I'm at work. I do a bit of AWS, and now I'm moving to an Azure project with Thomas, and then fully like Azure DevOps, maybe some GitHub Actions as well.
So actually, that brings a good question, right? Maybe for Thomas, because I know Nicholas, you said AWS and Azure. Thomas, you're purely doing Azure, and you're more focused on Terraform. So why Terraform? Why not Biceps or ARM or Uh,
Yeah, that's a discussion. I'm laughing. I've had the discussion quite often. I suppose.
right? I kind of opened the can of worms there, so I know.
We should actually do a session on that, to be
He's
honest.
throwing the heat already.
Yeah, so we've got the ARM v Bicep v Terraform discussion, and then every so often that Pulumi gets asked as well. It's probably the top
True.
four for definitely for Azure. I suppose Terraform. Why I like Terraform is Terraform state. I'm a huge fan of having something in state. I suppose I'm coming from, I came from an ARM background. I suppose like everyone in Azure, there was Azure PowerShell 8 years ago. ARM came along, that was cool, and then sort of Terraform came out of the woodwork with their various providers for Azure and AWS and other, I suppose, cloud providers and even on-premise and so on. And then from there, I've just really enjoyed, I suppose, Terraform. It is quite, I suppose, our topic is modularization. It modularized very, very well. And then Bicep came along and sort of introduced that avenue as well. And I suppose Terraform as well is cloud agnostic. I suppose a lot of our work in Kinos is keeping engineers somewhat cloud agnostic or specialize in certain areas. I certainly specialize in Azure. I've worked Azure probably most of my career in Kinos, so the last 8 years, majority of my time has been in Azure, from the old portal to the new modern Slick portal. So yeah, I've been around some time, and I've worked with a lot of, I suppose, infrastructure as code. And currently, my interest is Terraform. And I suppose, as I mentioned, the benefit is just the state and having state like that, and also somewhat cloud agnostic. Probably not for myself, because definitely an Azure fanboy, but the others like it because they can lift and shift and move across to other environments, or sorry, other cloud providers.
Nick, what's your take on that?
So the good thing is that it's multi-cloud, and then you can still, like, if you want to, like, if you start with Azure, and if later on want to go to AWS, you can easily learn it because it's still just one language you need to know. You don't need to learn multiple. So that's what I expect. And then you can see what you deploy. Like, when you, like what Thomas said, you can try the state and see what you do. It's not like Bicep, there's no state file. So when you do screw something up, you don't know what's going to happen, how you can fix it. So that's quite hard to troubleshoot. So
Makes sense. Makes sense.
Yeah.
Okay, so with that being said, we'll get the presentation started. We can do the presentation, do the demo, and then we can come back with more questions.
Yep, sounds good.
yeah,
Nick,
sure.
if you want to share your screen, and we go from there.
Yeah, sure. One sec. Computer. It's fine.
Well, while we're doing that, so thank you, viewers, and please, by all means, send us your questions during, after. We'll help moderate. We'll get you answers, or we'll try and find somebody who does know. So please get those questions off to us. We'd be happy to take them. So awesome.
Can you see my screen?
Yep, I think we're good.
Okay.
Yep.
So welcome. This is our presentation. So we're gonna talk about how you write reusable module using Terraform with myself and Thomas Dalton. Yeah. So
Sure. Yeah, so the agenda itself, I suppose, is somewhat action-packed. I suppose the overall synopsis of this, we're going to build or give a definition of how to write a reusable module, and hopefully you can incorporate that into your workload. So the agenda is going to be, I suppose, top to bottom. We're going to look at why create Terraform modules. Why should you modularize your Terraform against just having a numerous amount of resources? We'll look at, I suppose, deep diving somewhat into creating Terraform modules, a recommended way to structure the modules as well. There's various ways, pros and cons of each, of course. Creating design for usability, something that I advocate quite a lot, not just Terraform modules. Anything you do should be reusable, and so on as well, especially within a team environment. You can reuse, and again, it's faster time to market, or faster even developer velocity as well, if you go down that route. And we can look at using a Terraform module as part of your Terraform deployment. This is moving into sort of demo, Nick's going to show, and then we'll also finish with some best practices for those modules, and creating and kicking off your, I suppose, road to modularization. And also we'll just finish with a quick conclusion, and of course, I suppose, somewhat chat at the end, and see where we end up from there.
So, like before, as mentioned, so my name is Nicholas. I'm currently working as a platform engineer at a company called Canis. And in my spare times, I love like learning new technologies and try to keep my knowledge up to date. And what aside from hanging out with friends and family. So I'm quite active in social media. So you can find me on Twitter or LinkedIn. I've also got a blog on nicholaschangblog.com, and also certified in certain of the following: so Azure Administrator, Azure Fundamental and Security Engineer.
Cheers, Nick. Yeah, so I suppose we went through this slide a few minutes ago, so probably no point me spending much time here, apart from if you want to give me a follow on Twitter, reach out on LinkedIn, and of course check out my blog, and hopefully you can see my picture as well. That's from the MVP Summit. I really enjoyed that, I suppose, experience, and thought it was a pretty cool picture to include. So that's pretty much me on that.
So to give an overview, I want to tell you what's Terraform. So Terraform is a language that is a declarative language that you build resources in the cloud or on-prem resources. So you can also build it using different versions, for example, Terraform Cloud, Terraform Enterprise, and open source. There's in Terraform, there's few commands, typical commands, for example, Terraform init, which initialize your working directory and the plan, which give you a preview before you deploy your resources. And Terraform apply will be able to apply any resources you deploy to the cloud provider you want. And there's also Terraform destroy will be able to destroy your resources in the cloud. So it also work with the typical Terraform works with Terraform Core and Terraform plugin to workflow. So Terraform Core is the how it works is you have a write, plan, and apply. So the write is pretty much you write the configuration. The plan is be able to preview any changes, and then the apply is just deploying the resources. So and then Terraform plugin is download any providers like from Azure, AWS, or Google to your directory. So for your configuration. In Terraform, there's also a thing called TF state. So that's a single files that holds your configuration files, your Terraform files. So we have normally Terraform is quite popular. So they have different, it's being like on the right hand side, this image of different like global companies that use Terraform. So it's like AWS, Google Cloud, Cisco. So there are some of the major companies.
Cool. And I suppose just on that, Nick, there's a lot of documentation we can link at the end as well for them cloud providers and companies as well. There's various resources and whatnot. You can begin to build your modules from there as well. Cool. So I suppose you're probably wondering why create Terraform modules and why not just use the 10 resources you're going to deploy or the 100 resources. I suppose with bullet points on the screen. So starting off, increase maintainability. So you could be deploying the same Terraform across environments, across customers. It could be 10 environments, it could be 100 customers. So it include, I suppose the first main piece increases maintainability for Terraform code. You can lift that one module and carry it across to 10 customers to 100 environments. And within that one module as well, say for example, everyone's probably familiar with a virtual machine. So we're deploying 10 virtual machines for customer 1 and customer 10 is looking 100. And we can simply run one update in the module that can be deployed across all the environments as well. And of course, next into that would be your navigation. Of course, is going to be easier. So once you've got the modules, that's the heavy lifting of your, I suppose, infrastructure as code. There'll be more on that somewhat later. Nick's going to show a demo and how you would pretty much do the heavy lifting in your module, keeping that somewhat static depending on your code lifecycle, your development lifecycle. And your navigation is a lot easier once you've got the module created. Next, provided consistency, of course. The modules can be somewhat a source of truth for X amount of environments or X amount of customers, and updating the module could sometimes be interesting as well. But we like to keep our modules simple. And of course, I was going to say I preach that quite a lot, keeping it simple and certainly do not repeat yourself, whether it be Terraform, Bash, and expanding code bases from there.
So Thomas, what do you mean by the source of truth for when you mention that?
Yeah, it's interesting. Depends on your deployment strategy. So you could have 10 modules, and that would be the source of truth for your, say, your 10 customers as well. And depending on versioning and so on, if you version the module, things like that, you can have version 1 or version 1.x if you go down the Semfire route and so on. And that's where you can, I suppose, begin really ramping that up as well. And again, keeping consistency between customers and between environments.
So that would be that version control is quite very important to it.
Yeah, certainly version control in any sort of development like that. And also, of course, everyone's favorite source control. So keeping everything in Git, and we'll show later as well the way you can structure modules, monorepo versus, I suppose, single repository per module and so on. And I suppose moving down through that is next is removing environment drift. And again, I'm pretty much repeating, provides consistency as well, and allows you reduce environment drift. So you create your modules, and all the environments will deploy that same module as well, or all the customers, depending on your, I suppose, customer base and interests as well. But certainly if you're running 10 environments, that same module will be deployed to all them as well. So again, this is where it reduces environment drift. And if you've used Terraform before, you don't want to, or well, you don't want to try introduce any environment drift. Working with state files can be interesting when there's environment drift there. Next is code organization. So again, you structure, you sort of, if you're building a house, you want to understand the structure, the structural, I suppose, building from the ground up. So looking at that, we'll discuss that later as well. And of course, best practices. So that allows you to introduce best practices a lot easier, and I suppose a more simplified approach rather than having 5 customers having 5 different types of resources that they're deploying, rather having it all under one roof.
So what does it mean by environment drift, if it was for me? Yeah.
Cool. Yeah, so environment drift, I suppose, like anything, you're drifting from the source code base. So if we look at it from a Terraform perspective, and yeah, we can use virtual machines again. For example, if you create a virtual machine in Terraform with a SKU type of a B series, and someone goes into the portal and for some reason creates a D series edits it to a D series virtual machine, we'll be hoping your alerting picks that up. But if you go to run Terraform again, that's where the environment drift can happen. It's out of sync with your Terraform code. At different VM SKU, or if there's something additional on the virtual machine, for example, or something in your network has changed, your virtual networking and so on.
Yeah. So I would think that the important thing about reducing environment drift is that you want to avoid having major impact on your state file. So you want to reduce the blast radius that can.
Yeah, you don't want to introduce any blast radius. Your state file is a single source of truth, and again, depending on environments, on your organization, on your ways of working, you'll most likely have multiple state files. And I suppose that's a topic for another day, but I can cover that at the end. I can give an overview of that, my thoughts around that. For example, if you're running a, I suppose, enterprise workload, you'll have possibly a state file per component going down that model product component. So you can have a state file for your networking, for your virtual machines, or I suppose anything from there, your NVS possibly, and so on. It really depends the way you want to structure your state file, or sorry, state files. I'm a huge fan of multiple state files and not just having one. And again, that sort of lowers your blast radius as well if you did have environment drift.
So
Cool.
in this, so I'm going to talk about how does Terraform module work. So Terraform module is a set of configuration files that are in one set of folders that make up the module. So a module can be referenced by passing different inputs like variables. And you, for example, you can have a module like a storage account that define a set of like variables or account name regions, which are classified as variables. And you can reference other outputs from it, which will be from another modules, which will pass as an input.
Cool. Awesome. So structuring your Terraform module, you're probably wondering somewhat how would I structure that? So again, I sort of mentioned plan from the start. Think of it as you're building a house. You're going to build a solid foundation before you put bricks or wood on your house and so on. So certainly plan from the start. Think of it sort of even mapping a road trip, where you want to end up, what you want to achieve. And again, start pointing that down, even in a notepad or in a sharing mechanism, depending on your way of working. Certainly a lot easier if you're working from any sort of plan rather than deep dive. You want to build, I suppose, your whole environment, but you're unsure how you want to modularize or what you actually want to modularize. And certainly, I'll reiterate again, keep it simple. Enterprise workloads, as complex as it is, you don't want to have your code base so complex that it takes 2 weeks for someone to onboard and really try and understand what's there or what's out of drift and so on. And moving on, the sort of separation of concerns principles. So anyone who's coming from a developer background will probably have heard of that before. So my thoughts, you want to create your modules that are going to be, I suppose, different as your resources in different areas, and certainly don't create one huge module. That could be effective, but it can be an absolute nightmare in multiple ways. Maintenance is one. Terraform is constantly, or sorry, it releases new providers, updates. Azure is changing rapidly. Any major cloud provider is changing rapidly. So I would say at the time you create that one huge module, it'll be out of date, and you need to have a look at how you're going to understand work with updates and code management, how you're going to handle if there's deprecation there and your environment isn't ready to handle that deprecation, how you're going to run your Terraform and so on. So when you start splitting that out in the various modules, you can handle that a lot easier. So the separation of concerns falls into that. And of course, simplicity. Certainly no need for complexity. Anything I write or anything I introduce, I think of it from the most simplistic way possible. You want to keep it simple. You're working on a lot of environments or working with a lot of customers, a lot of code. You're looking at Terraform day in, day out. You want to keep it certainly simple. And of course, folder structure. I have a screen on that in a few slides down. We can talk in that more there. But again, similar to the separation of concerns, structure the folders in a way that I suppose is human readable as well. I saw a lot of interesting concepts of Terraform and modules in my time as well. And it can be quite tough, especially new people onboarding into the world of Terraform, into the world of infrastructure code. You don't want to sort of scare them before they get going as well. So yeah. I suppose the likes of folder structure and certainly keeping it simple.
Yeah, so a typical tool for like name convention in Azure would be like AZ naming tool, which you can find for GitHub. So it's quite you can just help you with the naming convention in Terraform.
Sure. Yep, certainly. And naming conventions as well. You want to have certainly a suitable naming convention. Naming conventions, again, there's so many different options you can do. You mentioned that tool there, Nick. The company, the customer may have a various naming convention they want as well. So it's somewhat meeting in the middle. And again, keeping it simple and try to think of iterations and so on as well, and numbering and whatnot. And try not to abbreviate too much. That can get not complex, but it can get painful over time.
So this is a typical structure of, this is an example of a module structure. So on your left-hand side, you see a screenshot of like a Terraform module example, which is calling a VNet, so virtual network. So in that virtual network, you have a virtual network.tf because all the Terraform have TF extension and outputs. And then we have a variables as well. So these are like inputs. And then you can see at the right-hand side, it's calling the root of it. So on your right-hand side of the screen, I see a typical how my demo will be structured. So it's structured between, we have these different modules like App Insight, NSG, Resource Group, Storage Account. And within the Resource Storage Account group, there's just different configuration files for Terraform. So like the main.tf is the main one, outputs and variables.
Cool. I suppose the next few slides, Nick, do you want to go down through? It just sort of falls into what you're speaking about there.
Okay, sure. So this is another example. So I'm going to talk about variables. So variable is how you pass it into modules as inputs as well. So you can pass these inputs and you can pass it as default on the right-hand side. So like right-hand side, we pass the location as default because those are static. And one thing I would recommend to try is that you always try to put it as a name. So give it a sensible name, your variable. So give it like a name, location. Normally I recommend you to choose like whatever you want to call it, like a network address group, we just call it the same name. So if you couldn't think of one to, and always like call it a description as well, so we know what was it for. So you can also, the main.tf contains resource to create a virtual network, and then that could include other subnets with it on resource group. So this is another. So I'm going to talk about output. So outputs in Terraform get return of values or information from a Terraform itself. So you on right hand side, you see an image, which is a typical, we start an output with outputs, and you give it a value, which is in storage account name. And then within the we reference the storage account, which is the name, the value SA, which that's what it's called. And then we can pass, we return the name, and then the second one is ID. You can also pass this outputs, reference it to a root module as well.
Cool. Cheers, Nick. Suppose on the next slide, I've added the word to this slide. Hopefully the image is doing it justice. An image I created a while back, and I share the blog post somewhat often, and it gets, I suppose, people talking around it as well. So on the screen is my recommendation of modularization and having your base Terraform root there, your base Terraform module, and going from there. So if you're running, for example, main.tf, everyone's familiar with, if they've ever ran any sort of example they've saw within HashiCorp or whatnot, usually call it main.tf. So we've got the main Terraform file that you're going to run all the Terraform from. That's the way it's sort of structured. Nick will show that in his demo. And it's calling out the various modules. And again, just on the screen, the SER module, AKS, App Insights, Key Vault, Log Analytics, and VNet module. So I suppose creating a simple Kubernetes cluster in this case. And I've kept it like this to keep it very simple. The likes of AKS module would just deploy the base recommendation, or sorry, the base recommendations that AKS has. So your AKS, the skill set, which is in theory in a node pool, and you could have application gateway for ingress, or if you're using like the traffic and Azure load balancer. Again, sorry, Azure load balancer won't actually deploy there. It will be deployed whenever you tell traffic or deploy traffic onto your cluster. Likes of ACR module, very, very simple. Azure Container Registry. App Insights, of course, Log Analytics, and then you're adding a solution to that, which is going to be assisting the likes of AKS. And of course, finishing with virtual network, so the subnets and whatnot in there. I certainly keep my modules very simple. I suppose when I post this online, there's for and against. And again, it can depend on your workload, on the way you're working, or your interests as well. I certainly come from a keeping it simple background, and is what I like to influence as well, if I can, keeping it simple. Again, you're running these modules to be deployed to 10 environments, and you could be on, I suppose that environment could live for the next 5 years. So you want to keep it simple as possible now. So in 3 years' time, you still understand what the module does, or someone new onboards on your project. It's quite simple.
Okay.
It's quite simple for them to pick up. Again, if you look at modules, there's readmes, there's running examples, there's running, I suppose, tests against that module as well. That's, I suppose, deeper diving than what this presentation is about. But certainly, if anyone's interested in talking around that, I could talk for all day, all weeks about my thoughts around Terraform and modularization. So certainly, huge interest of mine. But again, just to be side on this, keep it simple and try not to repeat yourself. Again, it shows multiple resource groups here. That depends on your strategy and your interest. You could have one resource group deploying it all if you wanted, or the separation. Again, from a costing perspective, from a way of working, there's so many thoughts around that as well.
So Thomas,
So-
since you have in the AKS module, you have AKS and a resource group, but its virtual machine skill sets, app gateway as separate resources, or it belongs to AKS?
Yeah, so whenever you deploy AKS, the actual resource, it needs what is called node pools. So in theory, they're virtual machine skill sets. It will run a system user node pool somewhat by default. You could have 100 different node pools depending on the size of your AKS cluster. And application gateway comes from an ingress side as well. So ingress is, I suppose this is an AKS talk, but ingress, for those who aren't familiar with, it's the gateway into your Kubernetes cluster. So the likes of application gateway, you've got your traffic, and Nginx is the other two sort of open source recommended ways as well. And there's various other ingresses as well. But that's probably the top three. Is quite common in any documentation as well.
So Thomas, from a
Sure.
module standpoint, where do you see the Azure landing zone module for Terraform coming in? Because I guess that's going to be the first one, right? That's the first
Yep.
module coming in.
Yeah, so landing zones, very, very common for any sort of customer engagements or working with customers now. And from a Microsoft side, they're really documenting landing zones and how they should be. Yeah, I certainly see when you're deploying a landing zone, you still need to modularize as well. So if you're deploying this sort of hub spoke, which is probably the most documented way possible and certainly recommended. You'd be deploying your hub spoke in one module, and then the likes of subscription management and so on could be in another. And then when you go into the spokes, it really depends. There's pros and cons, and depending on the documentation you look at. I certainly like to keep it segmented as well from a Terraform state. So again, moving back to, you could have 10 different states for your environment. So that in theory reduces the blast radius. If, for example, for whatever reason, you cause a conflict or a code drift within your configuration, it's only affecting that state, that part of your environment. Whereas if you had one file, the blast radius could be huge. Again, we want to mitigate blast radius, but we're humans, these things can happen. And yeah, it's all about trying to mitigate that, looking at your Terraform plans and so on as well. I suppose I've come across a lot of CI checks and whatnot to make it more human readable. Putting into your pull request, for example, is quite common. Traffic light system as well. So during pull requests, you can have a plan which shows no changes is green. If there's a destroy, it's going to be red, and any sort of changes is orange. So something like that as well is certainly very effective, and it's more into your strategy deployment strategies as well. Terraform's one thing; it's doing your deploying, but again, it's reducing blast radius and understanding the full life cycle. But yeah, sorry, I sort of went off scope there. So yeah, the landing zones, very, very good. And the likes of your adoption frameworks and frameworks that Microsoft certainly document. I still do like segregated or segmentation within your modules as well. And you're probably seeing that more and more. No?
Yeah. So that will include like you need to separate each environment then, because if you have like not sure how it will work, you have two separate companies and stuff like B2B, like someone buy another company.
Yeah, that's an interesting one. Again, that's probably a legal side. Companies buying companies and what they're going to do there. But you mentioned an interesting point: multiple environments. So if we have sandbox, well, if we go from sandbox to right up to your AAT or non-production into production, you could have your ITHC or perf test, all different environments. So I sort of touched on that previously. You still want to use that one module and deploy it to them 8 environments. And how you split that is what is called TFRs. So if anyone's come across TFRs, it's pretty much splitting the, I suppose to put it in layman's terms, if we have 10 virtual machines in Sandbox with different SKU sizes, you may want production to be more high powered. So within your TFRs, you'd be changing the values there. So it's pretty much the environment variables that are going to change as time. Or if you're creating virtual networks, depending on your networks, you could have, or depending on how you deploy, your sandbox network would be different to your production network and so on.
Yeah, because for that, you can also separate it between having multi-repo, so you can have a different repo for different companies. Can you structure it as well?
Yeah, that's an interesting one. Again, companies vary, or each customer you work with varies in requirements as well. That's probably a different topic for another day, and depending on customers you work with or their interests as well. But yeah, I would come at it from a keep making simple approach again, and look at what you've done previously. Again, that falls into customer IP and all the legal side of things as well.
Okay. So I'm gonna show you a demo. So how you create the virtual machine modules and everything. So one sec. So where is it? Can you see my screen? Sorry. I think. Can you see my screen? I was.
Yeah,
Okay.
you're good to go.
So to get started with the modules, you can see, like say on my slides, we separate it under environments, and then we call it modules. And these modules are different resources like App Insights, NSGs, and resource group. And like virtual machines, it will be a resource, how you create virtual machines. And to call it, once you create the virtual machines, these would normally call submodules. which can use to reference the root modules that in the presentation. So root modules can be called main.tf, or it's normally called main.tf, which is the root of the other modules we reference it. And then we normally reference it by the source. We call it name, we call it modules, and then we give it a value like storage account. And then we give this source for referencing, and then we reference the path of the storage account. So the storage account pointing towards the modules here. And then within the storage account have various inputs within the var.location, var.storage account. And the resource group is an interesting one because I've used this. I use these outputs, and I reference it from the resource group, this one. So outputs where I reference it because I call the outputs name, so resource group name. And when I click in here, so I use it. I click modules as well. So you module name, RG is the name of the values, and we reference the output, so it's coming from. So resource group name. So another ways that you can call module is that aside from calling it with normal local module, you can call it with through Git as well, or you can call it through Terraform registry or HTTP. So I'm going to show you an example how you can call it through Git. So this is through a GitHub. So when you install your module through GitHub, like this example, this is storing a key vault. So key vault in GitHub. And this is how I would normally call the path of the name of it. So the difference is that when you store a module in GitHub, you always give it a Terraform Agile RM, and then you give it the name of the actual resource .git. So this is the same. So when you can see the modules here. So on my GitHub here, it's pointing using the same modules here, Agile RM, Terraform Agile RM -key vault, and then within the repo, it would have the modules under the main.tf proprietors and variables, and you can give it any like folders with examples as well. So we call that. So the module can be public, which can be accessible. Otherwise, you can access it through path token as well to secure it. So let me go back. So what was the thinking?
I suppose just on that, Nick, if you want to. Yeah, so you mentioned it.
Environments. So there's an environment that have different TFVARs. For example, TFVARs could be like in bicep terms, values. So values that you pass in between in different environments. So I pass in environment names dev and then storage account name here. So these are hard-coded values that when you pass it through Azure DevOps or anything, you can pass it through runtime. Sometimes these are like changeable values as well. So we normally put in values here that's changeable on TFVARs that can be easily changed, like username, VM size and stuff. And we can also have a TFVAR per each environment, so it's easy to like deploy it. So like a dev, pre-prod, staging, and prod.
I suppose just on this, Nick, as well, the admin password is plaintext. So this is a demo. There's ways to hide that and so on as well.
So you can just use the word sensitive. So since there's a demo, I just want to see how you can hardcode password. So I wouldn't recommend hardcoding your password like this. So since it's a demo, you can use the sensitive values as well. So you won't see anything on your Terraform value. It just marks it as sensitive, so it's blocked out. Yes, so that's what. So a module is quite typical. It's quite easy to write because as long as you figure your path and then inputs. Sometimes you can actually hard code your values in modules. Like for example, you can hard code it environment as in dev here instead of using the TF files. As you can use it as an option as well. But normally you need to consider when you hard code values, you need to make sure those are it will be static. So if it's static, don't normally change it. So it's like a typical one would be location because you don't really want to change location.
Yeah. And then suppose in that as well, we sort of touched on our the image that I spoke about as well. We can see this is the main sort of root file that Nick is on at the moment, and I suppose all the heavy lifting is done in the modules itself and not on the root file. So I suppose the synopsis of this is we want to move as much towards natural language as possible. That's what everyone understands, I suppose, the fastest. So the likes of location, you can describe the var location, the VM size, and you're often building virtual machines. And if you look at any of the modules, Nick, you can see that the heavy lifting is all done within the modules each time. If you want to look, I suppose virtual machine is probably somewhat as a good example. So we can see there, again, it's all the heavy lifting is in there. If there's any changes, even the likes of VNet, I suppose these modules are quite simple. So again, the understanding, but you could have the likes of for eaches or any sort of interesting ways of working that the Terraform has, have that all sitting within your module itself. So again, all the heavy lifting is done. The module is done once, and when you come along and just having your root deployment, again, you want to be as, I suppose, natural language as possible.
So within the modules, like it doesn't really in the name of the folder, you don't really need to call it module. You can call it SRC, give it a different name, as long as you correctly reference the modules. Then you should normally call it from the root correctly.
Yep. Sure.
So,
sure. And
yes,
yeah, I suppose on that, Nick, if we show I suppose, the somewhat difference between monolithic v sort of single repository as well. So if anyone's familiar with monolithic as well, sort of all the modules are monolithic Terraform modularization. It's all sitting within one folder. So if we looked at this in source control, we could see is that 6 modules sitting there, all under one source control. So that's fine. But if we had, I don't know, 20 modules, and again, when you start running updates and your sort of automation for, if you have a Renovate bot coming along and it sees new updates, and again, it gets very interesting over time, quite noisy. You want to reduce the noise and sort of reduce even the blast radius on repositories as well. So there's pros and cons to a monolithic setup. And then Nick has the example as well where one of the modules is sitting off in its own area, where that's certainly useful for even adding the likes of readmes and suppose your way of working as well. There's TF docs, there's other CLI tools that can spin out readmes and start producing content as well that people come along and understand, I suppose, a more simple process when it's sitting on its own.
Yeah. So would you recommend to use monolithic repo, which is like typical repo that I'm showing you, or multi-repo where it should have different repo for modules?
Yeah, it's interesting, and depending on the size of your environment, if you're working on some enterprise workload, my opinion of that is have a single repository per module. Again, working on the likes of automation, Renovate, and whatnot, the sort of dependency checking, it's a lot easier to maintain, and you can even write tests during pull requests that can test your module, test the changes that it's recommending, and so on. So your automated testing is faster. Of course, you can automate tests for a monolithic repository as well, but that increases complexity. I suppose the end goal is getting as fast as time as possible, or at least time it takes for your pull request, understanding them, getting them into your code, so the real value is at the end users or at the end environments.
Yeah. So in this demo, you can also have like a stage file for dev and then pre-prod and staging, right?
Yeah, so you would run a state file per environment at least, and again, you can run state files per modules and so on as well. That's certainly a topic for another day. The state file saga, that is always interesting. But again, I sort of touched on that. I like to have multiple state files per environment. It reduces blast radius, and I suppose influences or increases somewhat psychological safety as well. It reduces blast radius, so I suppose everyone's somewhat happier when doing a pull request. It's not going to take down a whole environment if for some reason nothing's reviewed. Again, there should be pull request reviews, your Terraform plan reviewed. As I mentioned, the traffic light system is pretty cool, or a simpler understanding of how you review plans and so on as well. But that's down to organizations and your team's way of working and so on.
Because having multiple state files is very, very important, because you can normally do independent testing. So instead of someone accidentally do a apply or do a Terraform destroy, you want to reduce that blast radius. So you want to have independent state files so you can test it independently as well.
Yep, so certainly makes sense. Cool.
So I'm going to, like what I mentioned, you can reference other modules. For example, the storage account, you can reference the outputs like it showed you before. And then that will reference the storage account name as well. So it will always, the root of it will always be main.tm. And then with the child modules will be sub modules of it.
Cool. And suppose I'm just resetting what I mentioned previous. Design your Terraform modules for reusability. So when you're designing Terraform modules, writing Terraform modules, again, as I've mentioned several times, I'm probably repeating myself, but keep reusability in mind. And some best practices certainly to consider. Modularity. Design your modules to be pretty much certainly modular in their own way and self-contained. If you're making an update there, that's pretty much the update it needs. It doesn't need to have sort of dependency alignment between module A, B, and C, and all the sort of moving arms and legs that you can have as well. Certainly not fun at scale. Parameterization, and Nick, you touched on that in the demo as well. Use variables to parameterize your modules so that they can be customized for different use cases. And again, you want to create modules that could be used for various environments, various deployments. So going back to, I suppose, the topic of this, design your modules for reusability. Next, abstraction. Abstract away the details of how resources are created and configured. So this is bringing back what I touched on during your demo, Nick, in terms of you have the main sort of deployment file. You're abstracting a lot of the heavy lifting, all the interesting pieces. You move them into your modules. And again, anyone coming along can see pretty much straight away it's deploying a virtual machine with 5 disks or whatnot. That's the simplicity as you want to get to within your main sort of root deployment file. And of course, documentation. I suppose no one likes writing documentation, but it's a lifesaver over time. 2 years' time, you have an old module, you can sort of understand from the get-go, this does this, or this is that, and so on. And again, I mentioned like TF Docs is a tool. There's various other open source tools and so on as well to make your life easier with that.
Because within the documentation, you can also use it to document any modules that you wrote for another like project or stuff, so it's easier to adopt to different modules. Projects.
Yeah. Again, you write your modules, as I mentioned, sort of generic and keep them quite abstract. So you can lift from customer A to B or project A to B and so on. And again, there isn't much changes. Well, there's no changes. They're written generic. So all the changes is done within your, I suppose, your main repository again. So if we think at it from a natural language, or the simplest way is us to understand this VM name equals, say, Thomas, VM name equals Nick. We want to get down to that scale.
So I wanted to tell you some best practice of using Terraform. So normally it's been documented by Jacob. So it's some best practice, some how you can follow when writing your Terraform configuration file. So some of them could be adding versions. So version could be having that when you use modules and you want to avoid like breaking change, like latest module could impact your current resources. You would pin your modules to a certain volume, certain version, so it doesn't actually increase by itself when new modules being updated. and then you can also do it by testing. So you can also test your modules independently within, like, or what Thomas mentioned, having separate state files. So separate test file could have independent testing for you to work on. And so documentation is similar to what Thomas mentioned, but you can also is one of the best practice to document your work, just in case we came to an issue with our modules, how we write the modules, so new starter can naturally follow the documentation as well. So security is crucial in Terraform because we want to maintain the security of our, like, vulnerability in our code. So we want to use some of the Terraform tools, for example, Checkov or TFSec, to be able to scan our Terraform configuration that we write, because we want to write code has lowest vulnerability at times. So the best way is to actually keep checking, keep looking for, like, follow the best practice for security, and just minimize the vulnerabilities in our code, because any like code does have vulnerability as well. So even app code or Terraform code, we need to make sure it's less vulnerability. So like reusability. So reusability could be like, in that's one of the best practice, because you can also share the modules between different like projects and stuff. So store it in Git, and another the colleague could actually pull that module and reuse it as many times as possible. So I always use modules to standardize deployment. So modules is one of the best practice to, like, keep reusing. Like if you have configuration that you deploy 20 times, you want to just write it once so it can deploy many times as possible, so it saves time. So you can have a module that bring up a new environment because it's quick as possible if you need it within a time frame. And like what Thomas mentioned, always follow the KISS principle. So avoid keeping avoid writing complex code. So, and then keep it simple. So write code on that you can understand, your colleague can understand if it was a new starter, and just keep it simple and just see if they can understand it. Yeah, and just don't repeat code itself. So avoid copying and pasting, avoid like repeating yourself in the Terraform in code.
Cool. I suppose conclusion on that. So just on this as well, and I suppose reciting what Nick has said and what myself has said, the two principles: keep it, I suppose, keep it dry, and certainly do not repeat yourself. Again, that's for any sort of Terraform, not just modularization as well. And certainly look at following best practices. I suppose best practices as well is interesting. There's Terraform best practices and what they recommend, and possibly what yourselves as a company or as a customer will not recommend as well. That's fun. And then of course best practices that Azure, AWS, GCP, for example, include as well. So it's taking a mixture of all of them and building a product from there. Sometimes there's no right or wrong way. It could be the way your customer is working, or the way your customer wants, or the way that has been developed and so on. So there's best practices is always interesting, but try and keep that as the standard principle. But sometimes that can drift from what is called the best practice in Azure, but it mightn't be the best practice for customer A, B, but it's fine for C and so on. So certainly keep that in mind.
Yeah, because that could be like you can have a client uh, following the best practice, but sometimes it's harder to, in certain circumstances, to follow it because it means you have more work to do to change it around the code.
Yep. Yeah, certainly. Best practices can certainly be determined somewhat by various avenues as well. What's in Azure documentation is totally fine. Best practices, your frameworks and so on, but you align them to what you're looking to build as well.
So I want to. This slide is just more information where people can actually read. So these are some recommended like blogs and stuff. So like we Thomas have a blog on create, write, and use Terraform modules. So it's quite interesting as well. And he also there's two blogs that he wrote. And then we have some GitHub on GitHub as well. So some like step by step labs as well. I've also my side and so I've also got some blog on Terraform as well, and then there's more content from from Thomas itself on Terraform. So yeah, you can also scan my barcode on the right left hand side to get more information, resources that you need. And thank you for listening. So do you have any questions?
Awesome, guys. Well, yes, we have a ton of questions. So you guys did so great that we're probably going to be here for another hour or two addressing all of them, but that's okay. No, just kidding. So let's start at the top. Thank you. We'll say thank you everyone for watching, for giving such great questions. So the first one that we have so far was from Ramdas, asking about talking about Terraform highlighting immutability. Yes. Are there any instances where Terraform is not used for immutability?
Suppose I can give a go at that. It's interesting. Immutable infrastructure. That's not just Terraform. That could be any infrastructure as code in your way of working as well. On my side, or my thoughts around that, anything you deploy should be immutable. I suppose in the recent age, for sure. And unless it's the likes of your core hub. So if you follow Hub's book, again, your express route can certainly be immutable. Do you want to constantly redeploy that? The answer is probably no, or the environment will just go up and down like I suppose, a jack in the box. Again, it can be immutable, but there's certain areas you want to keep somewhat immutable from the likes of connectivity. If your customer sites or if you have various connections and so on, your VPNs and things. Again, in Azure, I'm trying to think offhand, I would say 99% is immutable. Do you want to make it immutable? Probably not. Your networking and so on, you want to keep it, I suppose, as mutable as possible. You want everything infrastructure as code. So if something does get deleted, again, there's mitigations around that. You have your resource locks, you have your IAM permissions, just-in-time access, all the cool things that Azure recommend as well. And if you look at, suppose, the ways of working the frameworks, it's documented there as well. And even down it's an interesting discussion point. Should a user be allowed production access? Most likely not. You would have just in time for that, for the break glass, and look at break glass accounts and so on as a topic for another day. It should be driven by your code. If your full infrastructure is code house, doesn't necessarily need to be Terraform. I know this call was Terraform sort of modularization, reusability there, but if you're running full bicep or full arm, or if it's something on the other side of the pond, again, you rely on your infrastructure as code. Your infrastructure as code is your source of truth, and this is where you rely on them sort of principles that what I deploy in production is all infrastructure as code. So yeah, hopefully that's somewhat answered. The mutable infrastructure. Again, Terraform is well catered for that. You've got your SZ API now. If the ARM provider hasn't got it, SZ API, you can write your own sort of piece to that puzzle as well, and also even updates during, if there's a brand new update, provider isn't updated yet, you can write custom Terraform as well to introduce in properties and so on. So from day zero, it's all there. But again, it's down to yourself if you want to make it immutable. Again, you can, but a lot of the times our networking and so on, you certainly wouldn't want to test the immutability of that. Like if express route connections or any sort of endpoints into your environments, you want to keep them fairly static.
Got it. And just one clarification, and I know I'm jumping around a little bit, but
Sure.
What about databases? So would we want to keep those immutable?
Yeah, they can be, but it's your data, so you want to keep them, I suppose, as static as possible. Again, if you're deploying Postgres, you deploy it using a Postgres module you create, or if it's Azure SQL, or if it's your blob storage, for example. Again, that's not databases, but it's still data in some context. Again, you need to look at your backup strategies and so on as well to ensure that's all aligned. You can make anything, I suppose, immutable, but do you want to start deleting your production data every day? the answer to me would be no. But again, yeah, if it's non-static content, there, depending
Unless
on
you're
the data.
recreating labs for your business, then
Yeah,
maybe.
yeah, sandboxes and so on. Certainly, to blow them down every day from a cost-saving exercise.
So
Yeah.
what would you think is like mutable infrastructure as code then? Will it like be Plumi, or because I know Terraform is immutable, so because
Yeah.
you can sit down and
Yeah, I suppose it depends. I took it from the aspect: do you want to blow your resources away, or do you not? So immutable, if immutable there. Again, yeah, the likes of Polymia as well. And it's quite somewhat static. Again, I haven't used it much. It can be a tough learning curve if you're not from a developer perspective. Developers love it, the devs love it because it's sort of their sort of side of the pond. I come from an old infrastructure background where you're writing PowerShell and Bash and you thought it was absolutely awesome, and then you're blown away with ARM, and then you've got the likes of Terraform now.
Awesome. Thank you. So, next question. I'm going to try and I'm navigating a couple of these because I think this came up 3 or 4 times, but I know you both touched on the passwords. So we did the whole clear text thing, and everybody's like, "Oh my God, I'm using the same password. I shouldn't do that."
Yes, certainly don't have.
So any recommendations, best practices, like how do you maybe we could frame it as how do you both regularly handle secure types of inputs?
Yeah, it's interesting. It can depend on what you're using. I suppose day to day, as Azure Key Vault for 101 secret management, of course, there's certificates and things around that. And then we deploy a lot using Azure DevOps to use variable groups. Feel free to check that out. Just to plug my blog, I've got a how-to on that. So you link your variable group to your pipeline. Your pipeline is as code, of course, and you link that to your key vault. So you've got your versioning and whatnot in your key vault, and then you've got your IAM permissions, and then you have your, I suppose, trace log to see who was changing what and so on. Very cool. So I suppose in short, key vault to me. But again, the likes of if you're a Terraform Enterprise house, you have secret management on that side of the field as well. And I suppose AWS would have somewhat equivalent in GCP. I'm not familiar offhand what they are, but they would have something quite similar.
Awesome. Yeah, just at least from me trying to simplify a little bit. So from that perspective, you're reaching out via either a web URI or whatever to get that value.
So you're ingesting them into your Terraform at runtime. I suppose the load down off that, and you keep them in the likes of a Key Vault or Terraform Enterprise or somewhere, which is secure storage in theory.
Awesome. Perfect. Abdul, do you want to maybe take 1 or 2 of these questions? I lost track of where I was.
Sure. So there's one question about how is documentation done in Terraform via comments?
That's interesting. Again, next demo had some comments there. That's fine. Again, it's interesting. I'm a huge fan of having as simple as code as possible. Even your comments, if you're adding lines of comments, your code's not simple. It's not, you're writing complex code, probably unnecessary a lot of the times. So you want to leave comments in code in general, to me, as least as possible. So 1 line's fine, or Nick was sort of demoing virtual machine and so on. But if you're deploying, I suppose, from a customer perspective, you probably have an understanding of it's a virtual machine and so on. In your modules, you may have an interesting for each loop. Again, for eaches and so on, you see that for I equals X and blah, blah, blah. Not a big fan of just having letters and so on. I can understand some aspect, but you want to have sort of a word there that it's doing for, I don't know, virtual machine and virtual machines, or for function and function apps, or for X. I'm trying to think of something else there, subnets and virtual network or something like that. You want to go down to that level. Again, it's down to how you write your Terraform as well. You want to reduce comments. Comments aren't fun. If you're someone new 2 years down the line, they don't want to spend 2 weeks reading comments to understand what this module does. It should be, you should have a quick README. And as I mentioned, the likes of Terraform Docs is a tool. Certainly check that out. It's an open source tool, and it writes pretty much the README for you. It gathers the necessary components, the resources, and outputs them into a README file. It's very, very cool.
Awesome.
Okay.
In that think it's better to break down each of the configuration. Like if you want to have one main.tf, it's too large like resources. You have to put it in another like another TF. Like it could be like vm2.main.tf, and it's add little comments. That's easy, but not too much. You see?
Got it.
One more question is, if you are connect two different Azure subscription, how do you make sure you are running in the correct subscription? What are the best practices for making a mistake? So
Yeah, that's interesting. I suppose there's two avenues that come straight to mind. If you're running, it's probably down to your pipeline. Again, if you're running Terraform in a customer environment, my gut feeling would be, well, I would be hoping you're running some sort of pipeline. So if we look at the likes of GitHub Actions, or if you're using Azure DevOps pipelines, you're probably running as what is called environments. So if you're deploying dev, your pipeline, so your GitHub Action or your Azure DevOps pipelines, understands that it's running a dev pipeline. So you're moving from your Terraform, so your Terraform is here, but you're going, I suppose, back to the environment itself. So if I'm running dev, you initialize that from your pipeline, and there's sort of belts and braces in there that it's going to initialize the dev subscription. The plan's going to be dev. So during the Terraform initialization, so Terraform init, if you've come across that, that's where you initialize. That's fine. So I could be initializing in dev, I could be initializing in production. That's all. Depending, are there multiple stages or different pipelines, depending on your strategy. That side of the fence is usually fine. But it's interesting when you want to reference 3 subscriptions in your one Terraform deployment. Again, you could have an example is I'm deploying a Kubernetes AKS cluster, but my SCR, so my container registry, is in subscription B. And for some reason, my storage account that I want to reference is in subscription C. So you go down to what is called providers and reference providers inside your Terraform. So you can create providers is pretty much a mechanism to understand that storage account, when you're deploying Terraform, you're going to reference provider C, which is configured to initialize into your C subscription. Provider B is going to be the B subscription, and then your standard provider is just going to be where you're initializing Terraform natively from. So it's first initialization. And yeah, so hopefully that's answered the question. The first is probably fine. Single environments, you initialize that during your pipeline. So it's understanding that way of working. And B is multiple provider initialization, or uses a provider. So it's down to that level.
okay, perfect. Thanks. One more question. Another question is, what is the difference between a module and a workspace?
Yeah, so this is enterprise world again. Your Terraform workspace is pretty much a combination of, off the top of my head, it's been a long time, but it's pretty much, if you're deploying dev, you have a dev workspace. If you're deploying sandbox, you have a sandbox workspace. If you're deploying production, you have a production workspace. So that's somewhat segregation there. That's fine, but your modules, you can reference your module and all them different workspaces. So yeah, the workspace is pretty much your separation of files, where modules you can deploy into 100 different environments from that same module.
Okay.
It normally does for isolation. It's like if you want to isolate environment, or like you want to isolate, so the workspace can be for only dev, like to play around with like deploy, destroy thing, and then you can normally do production. You do it without workspace, is so you can just do it for isolation with best.
Got it.
And then one more question was about, let me see, I just lost it.
Is it the TFRs one?
Yeah.
Yeah. Here, I can take it.
Sure.
Yeah. So Thomas, you'd mentioned TFRs, and somebody was wondering when you would use a regular var file over a TFRs file.
Cool. Yeah, so you use your variables file in any Terraform module, or in any sort of, I suppose, depending on your understanding of Terraform. So the root deployment, where you're initializing Terraform, if you're referencing var.x or var.environment, for example, or var.vm name, you need to have a variable reference there. So there's two different sort of avenues. Your variable references is what Terraform looks for, but your TF bars is pretty much what you can rewrite variables to. So your TF bars could be VM, say dev.tfrs, VM1 equals Thomas, VM2 equals Nick, VM3 is Chris, VM4 is Abdul, and then you have a variable called, well, sorry, whenever you go into your root sort of deployment again, you'll have variable VM1 to 4 declared there. But then when you go to Terraform your initialization, you would say your TFRs file is dev.tfrs. So and then your, say, production TFRs would be, say, our surnames for virtual machine names. So it's just two different sets of values that you run at runtime. So I suppose in short, you still need to have your variables in anything you do. So that's just your base. And you can set default variable values, which Nick showed in his demo. Or if there's nothing there, your Terraform will error and says, I don't know, VM1 needs it needs a value pretty much.
Awesome. I think that mostly covers the questions that we got from our viewers. Abdul, do you have any questions, any thoughts?
No, no questions. But thank you so much. This was great. A lot of learning, and especially you guys coming late. I know it's late in the UK. So, thank you so much for coming. Yeah,
Thank you.
that was absolutely amazing.
That was good fun. Awesome.
Yeah, so fantastic job. I concur. It's like this has been awesome. My mind's been expanded, so thank you both for that. I'm a little rough in some of these areas, so especially around Terraform. We'll just say that. So this is awesome. But thank you both. We'd love to have you back sometime. I know you mentioned a couple of different segues on different things, but great depth, great experience.
So
sure,
have you guys used Bicep before then? Take it or. Yeah, okay, so you prefer Bicep over Terraform?
I don't know. I don't. I haven't used Terraform enough yet to know.
Yeah.
So for me, I just need to dig in, and this will inspire me to do that. So awesome. All right. Well, with that, again, thank you all. Thank you to our viewers. Thanks for the great questions, gentlemen. Thanks for a fantastic presentation. The demo gods were with us. They smiled. Or goddesses, but again, thank you all. Please, if you're not subscribed, make sure to smash that subscribe button, and we'll see you next time on Come Cloud with Us. Have a great morning, day, night, whatever time it is. Take care, everyone.
Thank you.
Thank you.